Hey guys, welcome back to the channel. My name's Chris and this is Fully Defined. I'm here to teach designers and engineers how best to use SolidWorks. And in this video, I'm going to take you through how to reverse engineer in CAD a multiboard tile. You may have seen a previous video from me on my multiboard wall, how I designed and installed the wall. In that video, I briefly touched on reverse engineering of the multiboard tile so that I had a SolidWorks version of that file. And this video is all about how I went through that process. You could use a similar process for any kind of file that you're able to find online, any kind of 3D print file. If you're trying to remix that file in SolidWorks, this is a very handy sort of skill to be able to utilize. So let me take you through it. In any kind of example like this, you're going to want to try and start with the best possible file available. When I went through the Multiboard website, it took me to thangs.com, where their multiboard file library is stored. I found an example of the tile, simple 2x2 tile that I wanted, and I downloaded a couple of different file types to see which one would import best into SolidWorks. The usual suspects: OBJ file, STL file, and step file. Now, I'll save you the hassle here. I ended up using a step file, but it wasn't a file that actually had, for whatever reason, the solid geometry data within the file, which meant I couldn't build on it. Like, I couldn't rebuild within that file. I could, but I just wanted to start fresh. So the process I went through, and one that I would recommend, is actually opening up a second instance of SolidWorks and putting that side by side on your screen, exactly in the way that I've done here. And that means you can have one view on the left where you're working or referencing the model. So you can change to whatever view, you can have a dimension or a measurement set in that screen. And then on your other SolidWorks instance, you can actually build your fresh model without interfering with the existing geometry or the existing reference file. So the process I'm going through here is I've already had a look at the geometry of the existing part. I've had a look at what I think are the kind of features it's built from. So I'm trying to assess, am I using extrudes? Where am I using cuts? Do I need revolves? What kind of complicated features like sweeps, helixes, threads am I going to need to do this part? So I'm trying to set all of that up and think about that as I'm going through the process of recreating the model. In a similar way, with the Lego series I've done, where you're looking at a physical object and you're trying to analyze how you would build that from scratch. It's a similar thing with CAD, except you actually have generally the measurements that you can use, which make things a lot easier. And I don't actually do this in this project, but another tool that you can use throughout is to actually create an assembly file of the reference file and your working file. And then you can actually build very closely one on top of the other without referencing each other, like without a direct reference. So once I had a rough plan, I could see how the original file was built. I'm then using the SolidWorks tools, the basic geometry, in this case like a hexagon and chamfers, to create the first body of that model. Now we'll continue on with the video here. You could see that I measured the chamfer and then I just recreated the chamfer around each of the edges. And now my next step is I'm looking at those thread details, because those thread details, like if I'm 3D printing based on these files, I need them to be super accurate. All right. So the way I went about that is to create sketch geometry in the reference file, then dimension that geometry, because I'm going to assume that Jonathan, when he's built these files in whatever software he's used for the originals, he's not just making up random numbers for this stuff. It would be controlled. So in a lot of cases, it's going to be round numbers. It's going to be round numbers. It's going to be even angles. Okay, there's not going to be like a very small decimal point, odd number sort of dimension. Most of the time, it's going to be rounded numbers. So you can use that knowledge to your advantage when you're recreating, even if it looks like it's 0.1, 0.2 of a millimeter off. You can just round it. And generally that tolerance is going to get eaten up in the 3D print anyway. Okay, second time recording this because I had pause on the first time. So how far did we get? What have we seen? We've seen here that I made an obvious mistake when reading the geometry of the original multiboard file. I could put this down to a number of factors. One, just carelessness. Two, rushing. Three, dealing with different file types that often, the mesh imports, they can be difficult to handle. So it's not as easy to manipulate like a section view and look in different places. But yeah, in the end, like that's all my responsibility. So unfortunately, my entire multiboard wall has incorrect threads for the large holes. At the moment, I've been able to overcome that just through pure force, but it's not obviously as neat or functional as a normal standard multiboard tile would be. Obviously, I can fix my model, replace any of the tiles that I need if I needed to use that kind of screw mechanism in these holes. I'm not sure if I will need to do that ever, but I can if needed to. But what I do want to do is obviously edit this video that you're about to see. So this is the second time it's been published. With this section here, clarifying my mistake and how to address it and how to correct the detail. So let's go through that process now. This file that I've inserted here, this was an OBJ file. And if I go through to this one, this is my multiboard tile. Now what we have to do is change this cut revolve, because it's obviously now we know not cut revolve, it is a threaded cut. So we have to do what we did with a similar process with the threaded hole in this section and replace that element there. So I think we can just use that. I think what we're going to do is change this sketch. What dimensions does it need? We're going to add some, no, they're already 90 degrees. They want to be equal. What we want to do is our spiral, and our spiral is going from this to there, 22.5. So here's how we're going to do it. Circle, 22.5. We're going to go features, curve, helix, height and pitch. Height, we don't have to go very far. 20. Pitch, 2.5. Start angle, 0. Height, it can be much less, 10. We're going from this top face. We want to start at 270, and we're going down. So we want to go counterclockwise. We want to reverse that height. There we go. Clockwise, down. All right, that looks better. So what we can see now is if we look at this front view and we look on the front plane here, and we can see that this line comes down. It's going down here and down there, and it's going to be 2.5 between. So now it should be as simple as doing a swept cut. Our sketch profile is this shape. Our path is the spiral. Do you want to go both directions? So it's going to go up and down, and let's see the result. There we go. And you can see how it gets bigger and smaller. And that is going to be closely matching what we can see in this reference file here, where there's a very tiny cut over on this side, okay? Top and bottom, top and bottom. That's what we missed when we did it the first time round. So we're going to roll down. I'm going to delete the cut revolve, Octodriver sketch, and sketch pattern I need to include in this, cut sweep. Now it's patterned. Now we roll down, and then our file has been updated. Yeah, big shout out to D. Dispersion, YouTube. He noticed this issue. Thanks very much, man, for fixing me up on that one. And yeah, back to the rest of the video, guys. I could see then that the rest of the hexagons are a simple mirror. Okay, in this case, I did a mirror feature 2 directions, which gave me the first 4 points of a 2x2 tile. And within that mirror feature as well, I could select merge bodies. So it merged them all into one automatically. Now, the next element to create is the smaller hole, which is actually a threaded hole that's in the center of those 4 octagons. Now, this one's a little bit more complicated. Obviously, to get the hole itself is pretty straightforward. That was an extrude and measuring a hole size. But now what I'm having to do is look at the geometry of that thread and make an assessment again about how that's created. But in this example, this detail, the chamfer is the same top and bottom of this hole. Now what I'm doing is working out how to recreate the thread dimensions. So similar process to working out the cut revolve dimensions in the first example. Here, I'm sketching one profile. I'm using the center point for that circular area. And again, I'm assuming that a lot of the dimensions are going to be round numbered dimensions. Okay, so where I see a dimension, like I'll sketch the line, I'll add it, and I'll get that as close as I can to the actual points. I'll then dimension it, and if the dimension said like 3.47 millimeters, I'm rounding up to 3.5. So with a thread, recreating a thread here, the main thing to work out is the pitch of the thread. So that's the distance from center to center of those two examples. Once I knew that pitch, then I could recreate one of those sketch profiles in a certain position above the hole. I could then do a helix, and that helix would have a pitch matching the sketch that I could see on the left. And I just make sure that that helix goes all the way through the hole, so that when I do a swept cut, okay, that's following that, that's going to cut my thread for me. Okay, so you can see there with the helix and the cut revolve, that's now created that thread detail. And I'm just doing some checks to make sure that the dimensions I've got for those sections are correct. But once I'm comfortable with that, that little section, that diamond section with a threaded cut, I'm now patterning that as a body pattern, a linear feature pattern, 2 directions. In the end, I changed how I did that feature in the sense that when I first created it, I made it a separate solid body, cut the thread, and then did a linear pattern of that solid body and then merged it together. I do change that process whereby I merge the original diamond at cut extrude, and then I do cut the swept cut, okay, to that same body. So I'm just ending up with one solid body. I don't actually have multiples, which means that all my pattern features end up being features themselves, not patterning bodies, and not requiring a merge feature later. Now, this is really important because of my intention with the file. My intention with this file was to make it such that I've got one file, and in this example, you can see I've got a 2x2 tile, but I want to use this same file to make a 5x7 tile, a 9x9 tile, all the sizes, have them all available to me in one file, so that if I didn't need to make any changes or improvements to that file, I had full control in just one location and not multiple locations. But also when I created an assembly of the design for the wall, again, I've just got one file in there. I can manage that through configurations. So, and now what you can see me doing is going through the process of just tweaking those features to remove the separate solid bodies and make sure I just had one solid body the whole way through, and I was actually patterning features and not separate bodies. All right, so the last step, once I created those features and I was very confident with the accuracy of those first 4 features, now becomes a question of configurations and patterns to create, firstly, the 3 different types of tiles, where you've got, let's say, a corner tile, which doesn't have those spikes on it, a side tile, which has spikes on one side, and the other type of tile which has spikes on 2 sides. So this is the 3 types of tiles that Multiboard comes in. And then it's setting up all my configurations so that for all of the different sizes, 2x2, 2x3, 2x4, etc., I have a configuration there, and all I need to do is click and activate a new configuration, and the model will update and take care of itself. My grand plan being that I can put all these files into the assembly. I can select the different configurations that I need, get them all in the right position, work out how many parts that I actually need. And then those configurations that I use, they're the files that I export as files to send to the 3D printer. Of course, I could, as an alternative, just download the 3D print file straight from Multitile, from thangs.com, but I wanted to use my own here. I wanted to use my own here just to the simple purpose of, testing myself and kind of creating this from scratch as much as I am building upon what someone else has already created. Now, I'm not going to take you through that process of creating all the equations and the design table and the configurations, because as you can see by what I've been doing here, I actually had a lot of trouble. It's not something that I use regularly in my work, because my work, I'm not doing a lot of repetitive patterns. I'm doing a lot more one-off designs. So it's not something that I use regularly. It's something that comes up, every couple of years. I might have a project that requires some sort of equations and multiple configurations such as this. But what we'll do now, I'll switch over to the current file and I'll show you actually how it's created, how it's handled at this point. So let's jump over and let's jump into the file itself. So this is a SolidWorks multiboard tile. And you can see how it's built. I've split it into a hex portion and a peg portion. And I'm going to roll back in the feature tree just to show you exactly, how it's built now. Okay, there were some refinements from that first model. If I roll back up here, we can see we get the hexagon section, chamfer, cut revolve to get that detail. You can see the sketch that's driving that as well. Okay, so very round dimensions. 1.25 being the only one that's a bit off round, but 1 1/4, I'm happy with that. I've then created a sketch, and so this sketch, you can see it's driven by some equations. The X and Y dimensions, or the X and Y instances, are driven by some equations. And then there's a sketch pattern feature, and this pattern, the example that I'm in here, is the core tile that is a 3x3 size. We'll have a look at that equations table in a minute. That's the hexagon portion, and I'm going to rename that right now. Octagon portion. It's not hexagon at all. So drive a sketch. I bet I've got all the wrong descriptors in those titles, but anyway. And then we roll down to the peg portion of the sketch. So these are the pegboard holes. So this is a little bit different. We have the boss extrude here, which is filling in that hole. Okay. Again, pretty straightforward. Then we put in our sketch that's driving these diamonds. All right. In this version, it's 3x3, but in others, those numbers change. I then put my chamfers on the hole. I've created a plane here because I need to get the sketch exactly in the center of where that hole is. I've got a helix, which you can see here, and a cut sweep, which creates that thread, and then a sketch pattern. And then let's have a look at first the configurations. So, when I first built the file and I was setting it up, I started with the core version, which is this, the 2x2. So this is what you saw in the walkthrough. All right, we fixed the file. When I changed the name of that sketch here, that also affected my equations here. So I just need to fix those up. But now everything's pretty smooth. So the equations table, let's just have a quick look at that. If we go to configurations and we go to tables, we can go on the Excel design table, edit table in a new window. It's going to pop up Excel on the screen here. And this is how I created a lot of the configurations, because it was simple click and drag, fill in some numbers, do some formulas. I'm just going to press OK, skip that. What the configuration table here in Excel lets me do is create all these configurations in a much quicker manner than going one by one in SolidWorks and adding a new configuration. So look, I have a driving configuration for the core, for the corner. And for the side, you see the numbers there, 2x2, 3x3, they're the same. But then within SolidWorks, I have an equation that, depending on which of these three versions it is, it'll either subtract 1 from an X direction or subtract 1 from an X and a Y direction. And that's how I can control the number of those diamond sections with thread for the three different versions. So here we have configuration name is in column A, configuration description column B, it's just a duplicate. And then we have values for X and Y. So Y in column C, X in column D. And you can see there I've basically got, 2x2 going all the way up to 2x9. 3x3 going up to 3x9. 4x4 going up to 4x9 and so on. 9x9 ended up being the biggest size panel or the biggest size tile that I could fit on my printer. If you've got a larger printer, you could go larger with your sizes. Okay, I'll close that down. So yeah, that's how I built that multi-board tile. Now that SolidWorks file, I'm going to link that below in the comments, in my Google Drive, be a public file. Anyone that wants to have a look at that SolidWorks version, please download it, check it out. It is only available for SolidWorks 2023 users and above. But yeah, open it up, check it out, see how I built it, play around with the configurations, turn things on and off, and get a better understanding of how you can create sort of complex files like this. I'll also link back to Multiboard website, Multiboard on Things as well. Please check them out. And what I'd love to hear from you guys is what you'd love to see me build next for this wall. I have built a couple of light holders, some cable management stuff, a couple of hooks for some of my frames there, a couple of the custom product hooks over on the left. There's plenty more to come, but let me know what you're keen to see. All right, thanks for watching. See you in the next one. Hey, thanks for watching the video all the way to the end. If you enjoyed it, please like and share. If you've got any suggestions for other content, leave it in the comments below. If you haven't already, please subscribe. And there's some other videos here. Check out. Thanks.